You are looking for places, finally you found the scams. Imagine you are relocating from Toronto to Calgary for a job purpose. You posted on social media, you need an apartment. Someone reached out to you, he has the apartment and offered you with the affordable price. And you trusted him, you sent the deposit, and by the time you realized all is gone. So this is a scam, happens everywhere, every day across the world. Ladies and gentlemen, my name is Ismail Hossain. Today I'm going to present AI in the Loop, privacy preserving real-time scam detection and conversational scam baiting, which leverage large language model and federated learning. I'll be covering background and motivations, then problem statement, research questions, research gap. Then I'll describe my solutions, detail, the results I'll talk about, and finally I'll conclude with the takeaways we have. So we all are vulnerable, right? Because we all are using social media. So every day we have a lot of interactions. I mean, we are connected a lot of peoples and we are posting, commenting, reacting, sharing, all the things. So that means we are leaving our footprints on social media. And that's how the scammer found us through our activities. And we cannot get rid of these scenarios. The scammer tried to reach out through messaging app. He found us through social engineering and tried to reach out through messaging app and tried to exploit us. So for that, we need a smart digital guard. I mean, for our protection on social media, so that we can save ourselves, so that it is proactive. I mean, to detect the scam and also prevent the scam. So that brings some research questions, really. So first of all, can a system detect and prevent scams simultaneously during live conversation? And the second one is, can AI engage scammer in real time while minimizing the risk and privacy, preserving the privacy? The last one, can AI be updated by learning new scam scenarios or scammer conversational patterns? So to address the research questions, we found some research guests. There is no such kind of like smart solutions which can work proactively, detect the scam, and also prevent the scam through the scam baiting. And also the AI cannot update itself when there is a new scam happens. So our objective is to build a proactive, privacy-preserving AI system that detects, disrupts, and learns from scammer interactions in real time without centralizing any sensitive user data. So let's try to understand our systems. First of all, as we mentioned earlier, we have to have a smart AI, proactive AI. So we need AI models which can detect scam. For that, we have fine-tuned the AI models with conversational scam data. So then, and our model also fine-tuned with the, response generation part. So when your model is capable for scam generations, so we actually applied it to messaging app to calculate the scam risk score by taking the pair of the messages terms and calculating the average weighted average of scam risk score and checks whether the average score actually beyonds the threshold value or not. If it goes, then the system warns the user the potential scam is going on. Then the system asks whether AI should be enabled or not. After that, if AI is enabled by the user and AI starts conversation with the scammer, so AI actually, the system takes the AI response based on the utility functions. It takes the responses based on how harmful the response, how like engaging the AI response. So then like it's continuing the conversation. If the AI response going like beyond the privacy things, like it cannot answer and cannot preserve the privacy, we have also a threshold value which actually prevent or stop the AI to continue the conversation. And lastly, we have the federated learning because we want to update our model. If you experience the scam here, Think about your friend, other corner of the world, also might experience the same type of scam. So how your friend model knows the part. So you have to have a, I mean, knowledge share distributed training. So federated learning actually gives you a distributed machine learning framework where your local device model will will train, and then it will send the global model to the it will send the model weight to the global model. So the global model will be like aggregated by getting all the model weights from the local models. Then it will send back to the local models. And that means now with all the things, your model is updated by all the knowledges across the world. But here, the federated learning makes sure your data will never ever leave your device. So we have experimented with a couple of transformer models. So, and we see that for scam detection, they perform very well. But here is the questions. Our target is not only detecting the scam. We also look for calculating the personal identification information score, and as well as the engagement score. Finally, also we are getting the scam baiting. So only the LLM can do this multitasking. So we have picked like couple of LLMs. Here we are showing how LLM perform in terms of scam detections. So these LLMs are open source, available on Hugging Face. So these are safeguard model. So you see the three variants of LlamaGuard. One is MDGs. So because we picked the this safeguard model, because so as we ensure the privacy is preserved, nothing actually you are not losing your data, or you're not losing your privacy, so that the scammer cannot actually exploit yourself. Model instantly will understand whether any kind of exploitation or not. So you also actually evaluated in terms of generation quality. So I mean, with respect to perplexity, distinct 1, distinct 2, actually these two metrics actually calculate the diversity of the dialogue. And the dialogue ranking pretend transformer actually calculate whether the dialogue is engaging or not. We see that also it performs well for different data sets. So we evaluated by the human random 100 data set, 100 conversations with respect to realism, engagement, and effectiveness at scale 5. We see that actually our AI-generated responses performs very well when we evaluated by the human. And lastly, we have the federated learning evaluations. Here we see there are 3 settings. One is no DP, another is 0.1, another is 0.2. So DP means differential privacy. Here, actually, as we are proposing the federated learning, there is a chances of getting inferred, I mean, model weight informations by the attacker. So we want to preserve the model weights as well. So that is why we actually tested our system with the differential privacy. So let's talk about what we lack for. So this system actually takes only the textual conversation, no multimodality. And we have some synthetic data. Some are actually real data publicly available. And also we evaluated only 100 random conversations. We need more. And we need also the privacy and the accuracy trade-off. As a future work, we can work with the phone call scam conversations and multimodalities, as well as the scalable in the real life. So the key takeaways from this research, which is like we have a proactive defense systems, AI in the loop, and we all have also a smart scoring system, which actually scores the LLM generated response. And also our model will show that our model performs very well, and also we validated by the human evaluations. And finally, so we show that how privacy is preserved by the federated learning, and why we need the federated learning. Thank you all, and this is award winner business idea. So, and thank you all. If you have any questions, please come to our poster. I'll try to answer you. Thank you all.